This video is an introduction to system test in the context of complex embedded systems. So what is it about? In essence, the definition is that system test ensures quality of systems which may be complex and embedded. So the system itself is usually an integrated and organized set of components that brings hard and software together and usually fulfill a very specific set of functions. The fact that there are many components involved in the system requires a very sophisticated testing strategy and execution. And while the principles of system tests can be broadly applied in engineering and development, the focus is on software testing itself. Let's look at some examples of those systems. So we have consumer electronics that people use on a daily basis, like smart TVs or household appliances, also the area of smart homes. Then you have the automotive industry, where the car itself is not an embedded system, but it contains many of them inside the car, like infotainment or assistant driving features. Then, as everyone has a smartphone, which contains a lot of embedded systems like payment or wearables like smartwatches. Then you have robotics, where you have the classical industrial systems, but also the growing humanoid robotics. And then there are many other systems that needs very sophisticated testing strategies like aerospace or communication devices. So a lot of systems that lead to technological and human progress needs to be tested in a very sophisticated way. What is the actual scope of testing those systems? So in this slide, there's an overview with a lot of bullet points for those activities, starting with incorporating quality knowledge as a basis. Then you have the actual test activities, where integration is a subset of them. You have to handle multiple components of the system and take them into account of your planning, execution, monitoring, etc. And you have to manage human resources, test infrastructure, and all processes overall. Of course, you have to plan the test execution. You have to evaluate the influence of product variants or other factors of the product that influence quality. You have to set up, so design and operate the test infrastructure where you execute the tests. You have to specify the test cases or other test items like test sets, etc. Then you have to monitor, test, and all integration activities. You have to include many project stakeholders within testing or the project itself. You have to do problem management, which is very important. And you have to include and design test automation. You have to do a lot of reporting, set up metrics, KPIs, etc. Then once you reach a point where the system and the testing itself is growing, you need to enable scalable testing, and you need a certain flexibility and excellence in execution. So of course, not every project needs everything, and also there might be other activities that are not listed here. And depending of the project, this is done by one person, or in bigger projects split up in many different people of a test team. All of those activities within testing those systems bring a lot of challenges. So the complexity of the system itself, of course, adds also complexity to testing. And there might be therefore a lack of structure in the test activities. Then you have dependencies of components within the system that can lead to a lot of issues in test planning, execution, and the product itself, of course. And as you have multiple components, you may also have unsynchronized releases of soft and hardware that needs to be managed. And as components probably have several managers, there are different interests of them that also needs to be handled properly. And usually you have product variants that also you have to take into account when handling and planning test activities. And in complex systems, you usually have at least two different views on the product. So on one hand, you have the components managed by projects usually, and then you have the functions and the feature view. And not always those two go hand in hand, so it can lead to some challenges. And testing builds upon, so there are different test levels and areas that needs to be managed and that are interact with. And at the end of those test levels, you of course try to achieve a customer-like environment to simulate how customers experience the product, and that might also not always be easy to make sure that you have those environments. And of course you have politics of organizations that you need to navigate and operate within. And finally, test automation is something you would strive for, but when it comes to complex systems, that might be also not easy. To be able to manage all those challenges, there are different building blocks of the system test stack, starting with quality as a foundation. So it provides framework, standards, and is basically an area in engineering that is very well defined and links to all other development processes. And on top of that, you have the basis of system test, which defines the setup, test management, the test methods, the strategy, and handles all the test objects. Next are certain domains which act as pillars of the test activities. So for example, test specification, test infrastructure, test planning, problem management, and reporting. Then you have the team that you need to execute and that in the end do the actual work. And if there are multiple team members, you of course have a hierarchy, you need to lead them and manage them. And then you have the tools which can act as an enabler, but of course you also need to utilize test software. And all of those needs to work together in a proper way, so in certain processes, and you need to execute testing. And for that, in the end, you have defined procedures that make sure it happens in an efficient and effective way. And in the end, if you set up everything, you of course want to achieve sustainable and automated mechanisms of the testing activities. And all of those building blocks of the stack will be elaborated in more detail in following videos.